This is 6th grade arithmetic for lesson 131 and 130 and 131. We're going to combine and do 2 pages, but don't panic. It's just going to be part of both pages, and so I'll let you know exactly what I want you to do on those pages. And so I want you to make sure that you have out for lesson 130, it's 235 and 236, and for lesson 131 is 237 and 238. So if you do not have those out and ready to go, then go ahead and pause the video and get those together. Also, you need to have your protractor and your compass for this lesson. All right, we're going to get started with some review, and we have been talking about angles and how we are, and all the different sizes of angles. And so we're going to review a little bit of that. So I'm going to bring over our angle chart and see if we can't get the whole chart on there. Okay, so if we look at this, our acute angles are how many degrees, or within what degrees? Yes, it'll be less than 90 degrees for an acute angle. And it's the smaller angles, so they're kind of cute. The obtuse angles are how many degrees? Would be between, it would be more than 90 degrees and less than 180 degrees. Down here we have a straight angle, and a straight angle only has 1 degree that it can be. If it's 179 or 181, it's not a straight angle. So it would have to be 180 degrees for that. Also, the right angle only has 1 degree that it can be. And what is that? It would be 90 degrees, okay? So 90 degrees forms a square. And so if you remember from looking at squares, a square has 4 right angles because it's perfectly 90 degrees on every angle, okay? And so those are our angles. And you've got, we're just gonna move this back over here, and we're gonna look up here, and if we have a 65-degree angle, let me push that back up so you can see it. If you have a 65-degree angle, what type of angle is that? That would be an acute angle because it is less than 90 degrees, but it's not, and it's not greater than 90. What about 120 degrees? What type of angle is that? Yes, it would be obtuse. If you said obtuse, you would be correct. And then a 45-degree angle is what? That one is also acute. It's like 65. If we had a 90-degree angle, what would that be? Exactly, that's a right angle. And so we want to make sure that we know the difference in our sizes of angles. And so I'm going to let you go ahead and take your speed drill. There actually should be 2 speed drills that you're going to take today, so 130 and 131. So go ahead and pause the video and take those if your parents have them ready for you. If not, then you can take them at the conclusion of the video. All right, I'll give you just a moment if you need to pause that. All right, we're going to go ahead and move on to our circles. I'm going to bring this chart over that I've got. Okay. So remember, our circle is a geometric shape, and we look at the diameter and the radius, and the very middle of it is called the center, right? We've got our semicircle, and we have an arc, okay? The arc doesn't go halfway around The semicircle goes halfway, and the arc is just part of the way, and that one can be pretty much any size as long as it's not halfway. And the circumference is the distance around a circle. It is like perimeter for all of our other shapes. Remember, the perimeter is the distance around an object. And so the circumference is the distance around a circle. We have it differently because it doesn't have any sides to it. And so they have it differently, and we can't figure it out the same way. Okay, but our circumference has two different formulas that we can use for that. And so circumference equals pi times d, or c equals 2 times pi times r. Okay, and up here we have our chart that we've done before. We have a 7-foot diameter circle. Okay, if we have a 7-foot, if the diameter is 7 feet, how much is the radius? And what are we going to do to find that out? Okay, we're going to divide 7 in half. Now I know you all are thinking, but 7's not an even number. We're not going to get an even answer. You're correct. 7 is not an even number. And so it's not going to be completely even, but 7, if you do 7 divided by 2, 2 goes into 7 how many times? This would be 3 times. 3 times 2 is 6, minus 1. If we make our remainder a fraction, we will get exactly what we're looking for. 3.5. So 3.5 feet, okay? It could also be written as 3.5 feet. Either way would be correct. So that's how to figure out our radius. Now we want to find out the circumference. Now that we have our radius and diameter set for our circle, we're going to figure out the circumference, and then we're going to figure out the area, okay? So first of all, would it be easier to use the diameter or the radius to figure this out? It would be easier to use the diameter. So I usually go with the easier one, but if it's asking specifically to use one or the other, you need to use the formula that they ask for. Okay, so if we're going to use the diameter, it's pi times d. And does anybody remember what pi equals? And no, it's not the sweet thing that you get to eat for dessert, although that is good. But this pi is 3.14, okay? So if you said that, you are correct. And then our diameter is 7. So we have 3.14 times 7. And don't forget that we're going to need to have the feet on there at the end. So it's best to keep it on your problem. All right, so if we have 3.14 and we multiply it times 7, don't forget to put your decimal in the answer, okay? We've got 2 decimal places. Okay, 7 times 4 is 28. 7 times 1 plus 2 is 9. And 7 times 3 is 21. Okay, so I put my decimal there because I knew that I needed 2 places, and so I just put it in as I was doing the problem, and then I didn't forget. Okay, so 21.98 feet is the circumference. Now, do we need to put that as squared, or is that not for circumference? That would not be for circumference. Circumference does not need to be squared. It's area that needs to be squared, okay? So I'm going to put this up here so that we can move on to the area. Okay? All right. Our formula for area is A equals pi times radius squared. Or we write it pi times r squared, right? Okay, D is diameter, r is radius. We use 3.14 for pi. And that's how we show that, okay? I'm gonna move this chart because I need the space to write out that. But we have looked at the protractor, so we're gonna leave that there, okay? So A equals pi times r squared, what we just read on our paper. Now, in this formula, we cannot use diameter, okay, you guys? We have mixed that up before, but we can't use diameter because r squared does not equal 2 times r, okay? Remember that r squared is r times r. That's this number, 3.5 times 3.5, okay? So we're going to figure out, and I'm gonna use 3.5. You can multiply it as a fraction and put 7 over 2 and multiply times 7 over 2, and then you're gonna have to reduce it, or you can do it 3.5. Okay, 5 times 5 is 25. 5 times 3 is 15, plus 2 is 17. We put our 0 there. 3 times 5 is 15. And we carry a 1. 3 times 3 plus 1 is 10. Okay, we want to make sure that we're putting these in the right columns and adding them up. 5 plus 0 is 5. 7 plus 5 is 2. 12, carry the 1. 1 plus 1 is 2. And then you've got a 1. Okay, we've got 2 decimal places. That's going to go between the 2's, 12.25. That is our radius squared. Okay, so A equals 3.14 times, okay, I'm going to erase that, keep my answer, times 3.5 squared. And if you have a number with a fraction, it's best to put it in parentheses before you put the squared, because then you don't mix up the 2 with the 1, making it look like it's 12 over 2. It's just a simple way to make sure that you keep things straight. So 3.14 times 12.25. Remember that we are in feet as well. And then we're going to multiply to get our answer. Notice that we have a decimal point in both numbers. So we are going to have 4 decimal places at the end. So don't forget that you're going to add those 4. So 4 times 5 is 20. 4 times 2 is 8, plus 2 is 10. 4 times 2 is 8, plus 1 is 9. 4 times 1 is 4. Okay, put a 0 to hold that place. 1 times 5, 5, 2, 2, 1. When we're multiplying by 1, you can do that. Okay, and then we put our 2 placeholders, and then 3 times 5. Don't forget when we've got 3 numbers that we need to multiply all of them. 3 times 5 is 15. I've got a marker that was working. Carry a 1. 3 times 2 plus 1 is 7. 3 times 2 is 6, and then 3 times 1 is 3. Okay, we're going to add these up, make sure that we keep them in our columns. That's going to be a 5. 9 plus 2 is 11, plus 5 is 16. 1 plus 4 is 5. 7, 14. That would be 8 and 3. Now, how many decimal places did we need at the beginning of this problem? How many are in the 2 numbers? Yes, there would be 4. 4 decimal places. So we start back here. 1, 2, 3, 4. Okay, we want to round to the hundredth spot. We have 38.46. 50. So we want to round to this spot, the 6. Does 5 make the 6 go up or stay the same? Okay, 5 is our number that makes it go up. Anything 5 and above, so 5 would be one of those numbers. 5 and above makes our number round up. So 38.47 feet. And what do we need with our area? We need feet squared. Okay, so up here, we could put our answer, 38.47. feet squared. You could also put the letters SQ and square feet like that, or you can put the 2 above it, okay? That's how we do our circumference and area. On your first page, we're gonna do the first, I'm gonna do one problem on the board, and then we're going to, I'm gonna show you what you're gonna do on these pages, okay? So we can erase that. All right, with constructing angles, the first thing that you're gonna do is you're gonna use your straight edge of your protractor, okay? You all should have a protractor that I sent with your packets to your parents, so make sure that those come back when we come back to school, but that you use them for math, okay? All right, so the easiest thing is to take your straight edge of your protractor and use it to draw a line, okay? And then you can put a dot in here for your vertex. Remember, the vertex is the center of it's where the 2 lines intersect for an angle, okay? So we can draw an arrow, and we're gonna label this BC, okay? So B and C. And then you're gonna take this, and don't forget that you're gonna have to pick this up and that you don't measure from the line, but you put it in the center and your line is lined up, okay? And we're gonna get a 65-degree angle. So I'm gonna make a little mark where 65 degrees is. All right, I'm gonna fix my line that it erased, okay? And then I'm gonna line this up with the 2 dots. I don't know if you can see that on the screen, but I'm lining it up with the 2 dots, and then I'm drawing a straight line using the straight edge of my protractor, okay? And you can put the arrows, these lines actually mean that they go on and on forever in those directions, okay? So we have this labeled BC. We can label this one as A, okay? So we have an angle ABC. We can put our little arc symbol there, and this is 65 degrees, okay? So that is how you're going to construct the angles. For the first few, they've already given you the straight line that you would have at the bottom. So you're gonna take your protractor, put the dot in the middle or the center right on the dot of that line, and then you're going to measure for the degrees that it tells you. So the first one is 25 degrees. So it should be a smaller angle. So use your thinking on that to see, okay, so a 25-degree angle, that's not gonna be an obtuse angle, it's gonna be an acute angle. So it's gonna be a smaller one. So keep that in mind as you do this. You can also, if you need to, use a straight edge or a ruler to use along with it if you don't have, I know one of you has the one that has the arm in it, which helps, but those of you that don't have that one, you can just go ahead and measure. And actually, that's your size for the 25-degree angle. So it's not going to be very big, but it is, you're going to want to put that on there. Okay, so I want you to do all of this first page, page 235. You do not have to do any of the review on this page, but go to the next one and I have some for you to mark. So page 237 and 238, go ahead and get a pencil and mark the ones that I'm telling you, okay? So all of section 1, 2, and 3, those are pretty simple. I want you to make sure that you fill all of those out. Section 4, completing the chart, you only have to do A. Section 5, go ahead and do all of those because they all will add up. You can, at the end, add all those angles up and see if they equal 360 degrees, which is how much a circle should equal. So if they don't equal 360, then you've probably got some of your angles not quite right. And then number 6, do all of those because those are just writing the name of the polygon. And then flip it over, and on section 7, you only have to do A. Okay, remember what we set our compass to draw our circle. Is it to the radius or to the diameter? It would be to the radius. So make sure that if they give you, and they do give you the diameter. So make sure you figure out the radius and set it to that. If you're having trouble setting your compass, ask your parents. If if it's not quite right, as long as it's closer to the radius than it is to the diameter, it won't be a problem. And then in the review section, between sections 8 and 9, I want you to pick 4. Okay, so go ahead and you can get to work on that, and we'll see you next time. And next time is the test, so when you're ready for the test, go ahead and let your parents know, and then we'll see you at the next lesson.